I will try to find the resonant spot from which to talk. I think this is it. This means that if you disrupt me from here, I can destroy you with my voice. What? Adam, was that you? Where is he? It had to be you. A schmuck. Folks, you have 3 bars making an H shape. Find the moment of inertia about A, axis running through A, and about an axis running through B. These are thin bars. And then move on to a little bit of fun. This distance is R. Find, excuse me, the moment of inertia of this welded system of bar and sphere, mass M, about an axis running through A. This is A. Axis running through the page. Okay? Once you're done that, move on to this problem where you got this bar and a sphere or a disk, let's call it sphere, and you have something coming into, strike it and stick to it. You want to find not how far it bends this way after. Okay, that's a bit of a, involved calculation because you'll have something off axis, center of mass. Just find omega after. What is omega after? And then move on to this. You have something coming down this way. It also strikes at V. So here, we're talking about the, you can't ignore gravity, but we're talking about this object striking here at V. Right? When it gets there, it has V and it points that way. Right? It's not that you have to worry about gravity before it hits it. Same here. When this eventually gets here, it has speed V. Strikes inelastic collision here. What is omega after? And finally, this guy coming in at an angle, theta, to strike this point as well. Okay, what is omega after? So, what? You pick, don't matter. Okay. On the exam, we'll give you the liberty too. Okay. So let's call them spheres, all of them. Do you want them spheres or discs? If you want a sphere, put your hand up. If you want a disc, put your hand up. Okay, sphere. Hi, Alex. Guys, because of my Middle Eastern roots, I don't do democracy very well. Am I anti-democratic? Right? Did you know that, Jasmine, what do you want? The best form of government, do you know what it is? I would agree with that, but I would love to, democracy doesn't really work because you see what's going on in North America. You got corporations feeding you crap and you say thank you. It don't work very well. A dictatorship might work, but actually it's a benevolent monarchy where the king is actually good because, but that's also, so I don't think anything works.
No, for us as a president.
Yes, not president, because that's limited authority. No. Some sort of, yes, what do you want, Jasmine? Sphere is fine, yeah. Did I say sphere? Okay, guys, everything there is a disk. This is a sphere. To please everybody, okay? If you have I about A, put your hand up. Seriously? What the People, okay, your task is to, this is a better spot. Why would they do that? I don't think they designed it this way. This is not supposed to be, anyhow. Okay, guys, your task is to find I about A or I about B. Find whatever. And then I about B. So focus on these. I'd like to see some answers. I've been quiet for like 10 minutes. Unacceptable. I about B is what? So don't do anything else over there. Don't copy. We have lots of time. Just do IA, IB, you have everything you need. Okay, Julia? Okay, folks. So I about A should be what? Okay, right? So one thing you will need to answer this question. What is I of a thin bar about an axis running through the bar? 0. Why? Because it's, okay. What is I of a bar like that when the bar is over there? If this is D, what is I about axis, I don't know, axis something. So I is 0, okay? I about this axis, can't call it A. What do you want to call it? J is not a thing for axis. I about, no. Kareem, shut up. I about, no. Shh. Shush. I about C. How was that? Boring, but it works. All right, Kareem, you talk too much. I'm going to fry you. All right. So what is I about C? Who can tell me what I about? This is mass M, and this is distance D. What is I about C of that bar? What? MD squared. Why? Who the hell are you? Why? Okay, can somebody explain it to me in a different way? Why is I of that bar? Okay, guys, you know how to do I can't yell over your voices. There is over 400 people in the room today. Okay? So you know how to do I about a bar like this, right? That is what? 1/12 ml squared. Okay? Now I'm asking you, and now if you want to find it about this axis, you say, well, I about this axis is ICM. This is ICM plus this is D. So I about this axis A here, axis A is ICM plus MD squared. We know how to do that, right? But now this is interesting in that the axis is running parallel to the bar. How do you do that? Anybody give me insight? Yes, Thomas. That's maybe what he was trying to say. Right? Before I interrupted him rudely. Right? The bar can be thought of as being made of a bunch of point masses, right? So this is just a kind of a, intuitive explanation of what's going on. Each one has mass M, and they're all sitting at distance R, so they're a bunch of point masses. So the moment of inertia of this bar I is M1 R1 squared, and it's D squared, plus M2 D squared, plus M3 D squared, plus, and that's equal to D squared into M1 plus M2 plus, and that's equal to M total D squared, and that's the mass of the bar times D squared, okay? So we understand that this behaves like a point mass, right? Okay? So now, when D is 0, you get 0. So I is equal to 0, okay? All right? What's another way to see this? We talked about it from the point of view of moment of inertia of a point mass. Who could suggest to me another way to see this? I is, how can you show that I of this bar, if the bar is thin, I about A is 0. Why? Do you want to take another crack at it and risk being abused? What's your name? Eli. Do you want to take another crack at it, Eli? Why? How can you show that the moment of inertia of a thin bar is 0? No. Thin bar. Thin means 0. I know it's funny. A light means no mass, and thin means no. That's what we do in physics. Okay. So who's gonna show me why the moment of inertia of this guy will be 0? I mean, we know it's a bunch of point masses. That's okay. But is there another way to see it? Yes. So, okay. So what you're trying to say maybe is that if this is a cylinder, right? If this is a cylinder of radius r and mass m, so radius is r and mass is m, then the moment of what is the moment of inertia of a cylinder about an axis running center of mass? Why would it be mr squared over 2? Because it's a bunch of disks. It's just a tall disk, right? And you can show it that way. That would be ICM, if the axis looks like that, okay, which is I about A in this case, is mr squared over 2. And then when r reaches 0, we have ICM equal to 0 for a thin bar. Okay? Cool? All right, so we're going with that. So I about A here, I need to erase some of this stuff. And I about A then is what? I about A is I1, I2, and I3. Okay? And for 1 and 2, it is 1/12 ml squared, right? Times 2 plus 0. So 1/6 ml squared. Yeah? Is that right? Okay? So that's that one. Now, I about B is what? I about B is, well, 1 is 0, right? So it's plus 0 for 1, plus, now, this is moment of inertia of a bar about an axis running to extremity, so it's 1/3. 1/3, the mass is m, the length is L over 2 all squared, plus what? So for this guy, it's 1/3 m, it's L squared, which is L over 2, plus m, what? M times L over 2 all squared, plus m times L over 2 all squared for this bar, about this axis. So how do you add that up? What's your name again? Kareem, did you figure it out? No, I knew it. All right, all right. Okay, so guys, what is it? How do you do this math? 1/3 of and 1. So 4/3 of 1/3, right? 1/3 ml squared? Is that right? All right, that's what we get. Cool? What? I don't. All right, moving on. What was the question? Sorry. What? Here? Dude, that's like 4 weeks ago. Moment of inertia of a bar about the extremity. Claudia, can you please sort him out? Yeah. Chloe can do it too. I didn't see you there. Okay. Yeah. Come on, represent. Okay, I'm going to erase this mess. For what? For everything? I think it added up that way. I don't know. Maybe I'm wrong. L squared over 4 plus L squared 1/3, 4 squares. Yeah, just add it up. So L squared over 4 and a third is 4/3 L squared over 4. Final exam review, it's not quiz review. This is not, if you're ECE, this is not meant to help you with the quiz. The quiz's help is happening tomorrow in the lecture. This is the final exam. Okay, what? No more questions. If you guys, if you can't figure this out, you are going to fail. No, you're not going to fail. I'm just kidding. You'll be fine. I'm not saying you're not going to fail either. So, no, I don't know. Okay, guys, we need to move on. You can figure this out on your own at home, right? Take it home and figure it out. You have enough between this and the videos that will hopefully be posted by Monday. Okay, guys, so now you have the axis here, okay? We're not going over moment of inertia, but what kind of motion is this guy going to do? What is it going to do? It's going to what? This is the axis. It's going to, the whole object, this kind of awkward object, okay? It's going to go like, wobble like that, okay? So it's going to wobble about, go like this, okay? The whole thing. So how do you find the moment of inertia of this funny shape about the axis A? Okay? So forget this part. This does not exist. Work on this one now. It's an object. No, you just need to find the moment of inertia of Mansour about something on the ceiling. What? It's whatever. What? I don't know, Nikon. I have no idea. I'll look again. So, this is the axis, right? Stephen, that's the axis. And that's the object. Find the moment of inertia. Doesn't need anything else. No string, no bar, no. Okay, guys. I'm gonna have to use my voice training, otherwise I'll be running out of voice quickly, much sooner than I had anticipated. So I'd appreciate it if, how do I do this? Like that. And then, okay, so please keep it quiet. If I talk, please don't talk. Otherwise, we're not gonna go through much because Mansour will be like that. Okay. So okay. So guys, you have an object welded together, a bar and some sort of sphere, we said, and you want the moment of inertia about here. I mean, does this have to be connected to here? No. Like somebody could ask you, what is the moment of inertia of Mansour about that light? Or an axis, it's okay, md squared, right? I'm assuming I'm a point mass, which I'm not. Okay. all right. So, all right. So, guys, so I about A is the following. 2/5 mr squared, and m is m and r is r, plus m times 2r all squared. That's for the sphere. Plus for the bar, 1/12 times m times L 4r all squared, plus m times the d squared term. What is d squared? That's what we got to figure out. The only tough part of this problem is figuring out this d. You got this d, you got the problem. Okay? How big is that guy? How quickly can you get it? Luca? You wanna? So I'm hoping for no people in the videos because I wanna post them publicly at some point, right? Without the swear words and stuff like that. All the cusses. That is the distance at which the bar is latched from the bottom. What? Guys, the bar is attached to the sphere at this point. This is R over 4. That's what the bar is. Man, this is like an exam. The bar is attached to the bottom of the whatever, R over 4 from the bottom. That's all there is to it. If you can't figure it out, move on to the next question. And maybe you won't figure that one out either. Sonny's right here. Where is he? What? You can what? Oh, brother. Yeah. All right. All right, guys. So, if we have D, we're done because that's just this. This is D. Could somebody find D for us? How do you find D? I don't know. What? Well, that one here, and then what? And then you need that one. How's that one? Very cute, Claudio. Yeah, you need that one for sure. So that part of it is easy. Okay, that's just 3R minus R over 4. But we need that guy. How are we going to get that guy? There is only one thing you need. You need to solve this problem and get the grades. Stefan. And I'm fine. I don't need anything. It's you. Yes. What? Somebody, yes. Dude, no idea. It could be, might as well be speaking something else to me. I don't know. What? Can you yell? Nah. What? Oh yeah, you're saying go here to the center? Yeah? And then this is R, right? And oh, look at that. Stefan, this is R, right? If this is R, how big is this guy? 3R over 4. Can you get this guy? What do you do? Pythagoras, right? Pythagoras, the way it's supposed to be. Pythagoras. All right, okay, guys? So you use Pythagoras to find this guy. And then you use Pythagoras again to find this guy and check. You're done. You will do that at home. The putty or whatever this is, so we want to do this quick, okay? This hits here at the center, speed V mass m over 10, and you have that. What is the angular speed going that way? The full exam question, if it was asked of you, would ask you what? How much did it swing by, right? Okay, we're not going to do that today because the center of mass calculation for that guy, for the object with the m over 10 sticking to the side, lopsided, is not easy. It's not easy to figure that out. Okay, so we won't be asking that. We just want omega after, right? And the same thing, this thing here, right, comes in and sticks here, okay? What's omega after that way? And finally, this one here comes in at an angle, theta, strikes at the center here. What is the, now, how can we make this more exciting? Have it strike here, R over 4. Above, yeah, Stefan? All right, so, but it's not. It's right in the middle. Okay, okay. So 3 minutes, 2 minutes, 2 minutes, 2, 2, 4, total of 8 minutes. Let's see some answers. Omega, 2, 2, 4, okay? All right. All right, guys. So this is an angular momentum problem in that obviously, we have an object with this thing sticking to it, right? Moving this way at omega. So because we'll say what? L system initial is equal to L system final. And L system final is what? Easy. I total times omega. All right. Now, please drop your pens and pay attention to this part because L system initial is R cross P, right? If you have an object moving, this is R, this is P, okay? And that's MV, going this way. Now, I could do it over there and create trouble for myself, or knowing that it's going to strike here at V, I can do it here. Now, we're saying that we have to do it there because we're saying that this object will have that speed V when it strikes the disk or sphere, whatever it is. Right? So we go here then. R cross P. Now, what some of you are trying to do is to say that you have P coming in this way, and R is this distance here, okay? Okay, folks? So, yeah, so initially it's R cross P because initially, this thing had no angular momentum. And finally, the system has angular momentum, so what that means is the system must have had angular momentum before, right? And for a moving object moving in a straight line, the angular momentum is R cross P about the pivot, okay? So keep that in mind. So R cross P. Now, what some of you are trying to do is to say, okay, we're not going to use this R, fine. Let's use this R. What some of you are trying to do is calculate what? They're saying this is R P sine theta equal to I total omega, okay? And what they're trying to do is say, I'm going to calculate R and V and sine theta, okay? If you're trying to do that, put your hand up. But you're trying to do something else? All right. Okay. So this is okay. You can go and do that, but there's no need for this. Because all you need in R cross P is what? R cross P is R perpendicular P or RP perpendicular. Same thing. So what am I going to do in this case? All I need is, same as torques, right? All I need is, I will use this one here. Can I say that that's R perpendicular P? That reduces to that anyway, okay? So RP sine theta, that reduces to, remember, to R perpendicular here, times P, equal to I total omega. And how do you find R perpendicular? We go from here. R perpendicular to what? R is from the pivot. R perpendicular is from the pivot to, so you stretch the momentum out, and your R perpendicular is this distance here. That is R perpendicular, right? So that becomes what now? 4R plus R, 5R, okay? So now the problem that seemed complicated is simply 5R times MV equal to I total omega. The only thing left is to find I total, right? And to get I total, okay, so 5, let me write it down for you. 5R, okay, and this is the mass of the object, which is what? M over 10, okay? So 5R, M over 10V is equal to what now, right? The trick with angular momentum problems is sometimes to find the moment of inertia, okay? Can you take a minute to find the moment of inertia of the system on your own? Because we're going to be using it in the subsequent calculations. Okay, folks. So I will do it in one step. Please pay attention so you're not lost. The moment of inertia is the moment of inertia of the bar. 1/3. M is M. L is 4R. All squared. That's the bar. Plus, for the sphere, it is, did we say disk or sphere? Disk. 1/2. M is M. R squared is R squared. Plus M times 5R all squared. Okay? Plus for the putty, or whatever the object is, it is md squared, and that's equal to m over 10 times what? 5 r squared plus r squared. Done. Omega. No root. It's a square. You don't. That's the way the cookie crumbles, man. Okay, so folks, oh wow. This is the spot. That's the spot. All right, so hello. Anyhow, so this problem can be really interesting if we start to ask you how far does this object swing from the vertical? It gets really nasty because the bar and the disk are easy to track, but the point mass will be difficult. You have to ignore the mass of that one or figure out the geometry, and it's just not, okay. So now moving on then, the moment of inertia in this problem here, we have the object coming down to strike us here, okay? And so, Shruti, what do you want? What? That's for the sphere. Oh, yeah. Thank you. Thank you so much. Let me correct it with, that's very precious, Shruti. You happy now? Yeah. No. What's she talking about? Yeah, of course. Yeah, that's right. I got it. All right. 5R. Oh, anyhow, okay. Does anybody have a value for this moment of inertia? What is it? According to Claudio, I about A is 1,003 over 30 mr squared. Okay? Maybe, I don't know. After this, if you wanted to go and calculate how much this swings by, you have to use, okay, so during the collision, we don't conserve energy, mechanical energy. Why? Because it's inelastic. We conserve mechanical energy after the collision. During the collision, it's only angular momentum. Now we have the moment of inertia of the object with the putty. The putty is going to strike here, okay? What is omega going this way, right? So, guys, take 1 more minute to finalize your answer for this. 1 more minute. You have the moment of inertia, use it, but the trick now is what is the angular momentum of the system before and after. So again, we have L system initial equal to L system initial equal to L system final. Okay? How are you going to do that in this case? Kareem. Okay, guys. The minute is up. Please pay attention to this part. How you do this is as follows. You say, L system final is I total omega. Omega is unknown, okay? Now, L system initial is what? That strikes here, guys. So again, it's what? R cross P. But P is now this way. Okay? So what do we get out of this? R cross P. The R is there and the P is there. Again, what can we do with this, guys? This becomes R P sine theta equal to I total omega. And I'm going to, again, why? Because as engineers, you are gifted with the ability of spotting perpendiculars. That's what is assumed in space, right? Otherwise, especially if you're a mechanical engineer. Managements are forgiven and ECEs are forgiven that way too. No, this is, guys, this is part and parcel of what mechanicals do. If they don't get this right, they're in for a very interesting second year. Management's no problem. ECE is no problem. Okay. Guys. Okay, so again, using our gift for spotting perpendicular distances, this becomes what? R sine theta is, again, same trick, R perpendicular times P equal to I total omega. And Kareem, what is R perpendicular? People, an essential skill to engineering design when it comes to structures is spotting perpendiculars. Because cross product, okay guys, I said that mechanicals only have to know this, or they are, but ECEs also, actually, to correct myself, it is incredibly important for ECEs to spot perpendiculars. Why? Where do perpendiculars show up? When you have what kind of product? Cross product. Cross product, you look for perpendiculars. Okay, for mechanicals, this is structural. For ECEs, where does that show up? Cross product, do you know? Pay attention. ECEs, pay attention. This course 105, you take it just to be able to take what? It's very important for you, but you take it to be able to take 106. Okay? In the first half of 106, you don't deal with cross. It's broken up into two parts. 106 is electricity and magnetism. Electricity is all about dot products. Okay? We'll see that in 106. Magnetism is all about cross products. You've got to be able to do cross products. Okay? So this rule, that rule, it's all, okay? So where is this R perpendicular P? How do you find R perpendicular? Guys, he did it wrong, but it worked out. How do you find perpendicular? What did you do here? This is the pivot. This is P. You stretch P until you find the perpendicular, okay? That is R perpendicular, this guy, okay? You stretch P, you extend P this way and that way till you find, now what do you do here? You stretch P this way and that way, okay? Till you find what? R perpendicular is this distance, which is the same as that distance. So this problem reduces to what? M, V equal to I total omega, which I total you have, and you can get omega. All right? Now, on your own, in another minute or so, do this one. On the course websites, both, I am seeing that my voice is going down, and thank you for being quiet while I talk. On both courses, you will now see under my notes, which were empty for the longest time, you now see videos and a story about ink and oil and coffee that I put together. Really, and I liked it. And you see also some other stuff. And there is a folder that says Notes Jory. Okay? Notes Jory are these awesome notes. I like them. They're better than anything I've done so far for this course anyway, other than the textbook. Right? They're really nicely laid out. And Jory Clements was kind enough to give them the, stand up, Jory. So a big thank you. Just to be clear, this is the mass of the putty, which is what? R M over 10. V is I. I'm going to forget that because this is just small m for the putty. Right? M equals to. Okay, so here, the same problem, but we're adding complexity. Okay? We're adding complexity in that now, how are you going to do this? Where is this R perpendicular times P? I don't see it. This is R, P. This is difficult, guys. So R, pay attention here. R cross P equal to what? R, P sine theta can be seen as RP perpendicular or R perpendicular P. But both are amok. How are you going to calculate R perpendicular to P? What are you going to do? You have to create, what do you want, Eli? What? Sure. Go ahead, buddy. You got to do that, but something else as well. Okay? Indeed. Excellent observation. Okay? And the reason we want to do that is because if you're looking for R perpendicular, it's okay. You can do it. Okay? But you have to find this distance. And if you're looking for P perpendicular, it's also a bit of a muck. So what Eli is saying is that we are going to use our knowledge of linear algebra, right? Hey, yo, guys. We are going to break up the vectors into what? What are engineers good at? Perpendiculars. So, guys, pay attention. R can be broken up into Rx or R horizontal plus R vertical. Right? That's R. Yeah? Any vector can be broken up into this and that. R perpendicular, R, what is that? Vertical, R horizontal, okay? So same with P, guys. Same with P, crossed with what? P what? Horizontal plus P perpendicular. These, P vertical, okay? These vectors make up P. These vectors make up R. and they are in rare approaches in first year physics or math, they're treated like full vectors because that's the way things started. When we did this many years ago, people treated components as vectors. That's exactly what they are. Why are components of a vector actual vectors and not just scalar? Because you don't add apples and get a watermelon. Right? Not in this world anyway. Okay? So here, guys, each vector is broken up into components along an axis grid. What's my axis grid? Vertical and horizontal. Okay? So now, on your own, factor out this cross product. Guys, what is this cross product equal to? Can you do that? But we can, but it's work. It's a lot of work. Shiv is asking, why do we not do whatever? Because it involves work. As an engineer, you have to subscribe to the principle that engineering is applied laziness. What does that mean? You want to get the result with the least amount of work. Am I right, man? Yeah? You don't want to, I mean, in physics, we throw all the money and stuff at something that we might get, we might not get. We're looking at stuff that, I don't know, maybe somebody will use in 400 years, like, I don't know. But, I mean, is this bad? No. It's just the way we do things. Maxwell was, Faraday, Maxwell, we're looking at stuff that we used hundreds of years later. Okay? With the quantum revolution, things happened a lot faster. But, I mean, gravity, Einstein's gravity, we are not clear on the technical applications of it yet. Okay? But something huge will happen probably. So it's okay for us physicists to spend time doing things that lead nowhere, right? But for engineers, no, you gotta get paid for this stuff. You don't wanna be, All right, so folks, R horizontal cross P horizontal plus R horizontal cross P vertical plus cross. Okay, bear with me, please, guys. We are almost done with this part. Bear with me to get it to a conclusion, okay? What does this reduce to? R horizontal, help me out. This cross that is what? 0. This cross that is what? 0. Reduces to R horizontal cross P vertical plus R vertical cross P horizontal. And what is that? That is R horizontal, P vertical, sine. What is the angle between these guys? 90. Right? Plus R vertical, P horizontal, sine 90. That's 1. So that becomes R horizontal, P vertical, plus R vertical, P horizontal. The trick now is no longer calculating moment of inertia. We have that. Okay? We have the moment of inertia. It's the same for all three. The trick is to figure out the angular momentum without having to do angles and God knows what. You spot perpendiculars, which is very important for you guys. You're home free. So that becomes what? R horizontal, P vertical plus R vertical, P horizontal. What are these values? What is R horizontal? R horizontal is what? That component of R is what? R. So R times, what is P vertical? P sine theta. Or let me do MV, okay? Just to, okay? This is R horizontal is this guy. R vertical is this guy. Okay, here. And P has two components, what? P horizontal and P vertical. Okay, and they're very easy to spot. R horizontal is R. P vertical is M over 10 V sine theta plus R vertical is what? 5R times P horizontal is M over 10 V cos theta. Okay? This probably today, for both mechanicals and ECEs, is the most important lecture to take forward. Okay? For the next courses. Okay? The cross products come up a lot for mechanical engineers and their dealings with torques and gears and stuff like that. And for electrical engineers in terms of dealing with magnetism. Absolutely essential.